Hello everyone, welcome back to Coding Intuition. Today we are going to solve largest color value in a directed graph question on Leetcode. So let us just quickly understand this question. So in this question we are given an graph. Basically graph is given like this and it is a directed graph, which means that you cannot uh, go back from 2 to 0 in this case. You can only go from 0 to 2. So it is a directed graph. Basically you can go from 0 to 1, 0 to 2 and cannot come back from 2 to 0, and you can go from 2 to 3 as well. So you are given a directed graph and you are given a color for each and every node. So this color string represents the color for each and every node. So it is basically the index that represents the node, and the value represents a color. So first node has A color, second node has B color, and the third node has similar color, as you can see, which is A. So that is representing the colors. Okay, so that is what is given to you in the question. Now what you need to calculate is you need to find out a path in which there are most number of similar colors. A path in which the number of similar colors is maximum. You need to find out that number, that maximum number, when the similar colors are in a single path. And what is that maximum number? For example, in this case, in first example, you can see we have a 0 and 2 3 4. So in this path we have a color three times. Okay, basically the red color shown here, the A color is three times in this graph. So that is for this case our answer is 3. And if you see in the second example, we have a cycle inside our graph. So whenever we have a cycle inside our graph, we will always return -1 from this question. Okay, as mentioned here as well. Okay, so if a graph contains any cycle, you will have to return a -1, and otherwise you need to find out any path in which there are most number of similar colors. As in this example, the similar color is A here, and it is occurring three times in this path. Okay, so that is what we need to calculate. So I hope that makes the question very clear. Now let us just move to whiteboard to understand the intuition and algorithm for this question. Okay, so to solve this question, we can use an algorithm called topological sort. And what is topological sort? We will understand that as we go through the algorithm, and we will understand the intuition behind doing the topological sort as we go through each and every step of this algorithm. Okay, so let us just quickly understand what we need to do inside this algorithm. So what we need to do inside the question, we need to find a path in which the path in which the similar colors are at the maximum number of times. Okay, so what we will be doing is, first thing we will be doing is we will be creating an array in which we will be storing the incoming edges for each and every node. So for 0 we have no incoming edges, we have 0 incoming edges, and for 2 we have one incoming edge, and for 3 similarly we have one incoming edge. So there could be multiple incoming edges as well. As so let us say there is a node here and that goes to 3. So in that case, there will be two incoming edges for our 3. So we will create an array in which we will store the incoming edges for each and every node. Okay, so that array will look something like this. Okay, so here is an example of incoming array. So each and every node, we can see that each and every node have only one incoming edge in this case. So what we will be doing in this case, so firstly we have calculated the incoming edges. Now after that, what we will be doing is we will see the nodes which have zero incoming edges. Okay, which have zero incoming edges, we will start iterating through the graph from them. And as soon as we go ahead, we will decrease the incoming to minus we will decrement the incoming value of its children to -1. So we will basically pick up in the next time we will pick up the values whose incoming values are 1. Then we will pick up the values whose incoming values are maybe 2. So that's how we will proceed in this algorithm. So this incoming array is to tell us to start our algorithm from which node. So we will be going through the nodes which whose incoming value is 0. So first of all, in our case we have only this node, so we will start iterating over this. Okay, so as we iterate over our array, we will also store one more thing in a 2D array. We will, for every node, and as we have seen in the question, that colors are in in lowercase English alphabets. So it is mentioned inside the question that value of color will be always be in the lowercase English alphabets. So for every node, we will create an array in which we will store the number of times a color is occurring. Okay, so that will look something like this. So what is this array is saying? So for each and every node, which is 0 1 2 3 4 in our case, we have created this array. Okay, let me and we will initialize it to 0. So this array will look something like this, and we will initialize it to 0 initially. Okay, so we will initialize this array to 0 first of all, and as soon as we encounter any color for the particular node, we will increment that. And for the neighbors of the particular node, we will say that your color should be maximum of these. So let me just explain you by iterating through it. So as we go to 0, and we will say what is your color. So its color is basically A, so we will increment 1 at A, and B and C and up to Z will remain same. Okay, now we'll move to Z2. Now we will move to 1 and 2. So let us say firstly we move to 2 1. So now as we move to 1, we will say that your color is B, so we will increment B to 1 in this case. And when we have traversed 0, what we have done, we have put it the value of A inside is childs, so we will put the value of A inside is child, which are 1 and 2. Why we are doing that? We are saying that if you are my children, you will be on the same path. So the count of color for this color for you would be at least this. So we will pass on this to our children, and we will be calculating maximum of this value and our parent value. So for in this case, this value is only 0, but there could be a case in which we are coming all the way from somewhere else. Okay, so there could be multiple paths to reach a particular node. In this, there is a single path to reach a particular node. So there might be a case in which the value is already existing here. In this case, it was 0. We have initialized all the values to 0, but there might be a case where a larger value might be existing here. So we will take maximum of already existing value and its parent value for this color. So for now, we have put it A here, A's value here. Now as soon as we move to 2, we see it has it again has a color A, so we will put a 2 here. Okay, so we have put it 2 here. Now the children of A is 3, so we will put again 2 here, and it has color C, so we will increment C. And our 4 color of our 4 is again A, so we will increment that when we go to A. So we have incremented that here. So that's how we will calculate maximum of all these values and get to our answer. It will be very much clear when we will move to the code, and I will explain it much better when you see the code. So let us just move to the code now. So here in this code, first of all, as you can see, we are creating a adjacency list. Basically, we are saying that if a node is going from 0 to 1, let us just put it as an index and push the value there, so that we can directly go from it's directly go to neighbors of the any node. Okay, so and firstly we will create adjacency list, and after we create adjacency list, we will uh, also calculate our incoming edges for each and every node right here. So basically 0 is incoming in 1. Basically we are going from 0 to 1, so that will add one edge for this guy. So basically we are increasing our incoming edge here. That's how. Then we will create a color count. That is what we have seen on whiteboard, that for every node we will have 26 values, basically for each and every alphabet of each and every lowercase English alphabet, which is our colors. For each and every color, for each and every node we have value of the color, and we will increment that as we traverse that color. So that's how we will proceed in this. So as we have discussed, the number of nodes which incoming value is 0, we will start our algorithm from that. So we will push them, all of them, in our queue. And first of all, we will process all of the nodes whose incoming value is 0. Basically for those nodes there is no basically there is no children for them. So we will first process all the nodes which have incoming value of 0. Now as we process them, we will increment this counter, which basically tells us that the for the current node, this color should be incremented because the current node has this color. Okay, and all over the answer will be the maximum of this. Okay, as we have seen on whiteboard. Now we will iterate over every children on this node, and we will decrement the value of incoming, because basically whichever child of this node we are traversing, we will basically reducing is in its incoming value, and that's how we will traverse that in the next call. Okay, so we basically go to its child whose incoming value is 0 in next call. Okay, so if the value of incoming child has now become 0, we will just push that inside our queue, because we have to iterate that in our next iteration. And for each and every value of the color, basically for each and all the colors, we will check whatever is its parent's value, or its value of itself, because there can be a value in that node originally, because it is coming because there could be the multiple paths from which it is coming. So that is why we are updating the values for each and every node. So that is why we are updating the value for each and every color here, because there could be the cases where we are coming to one node from multiple paths, and there could be a value already existing for that. Otherwise it will take the value of its parent. That's why we are doing this maximum values of all amongst them. Okay, and at the end, if the total process nodes are not equal to n, which means that we will never be able to process all the nodes, because it is a cycle. If it is a cycle, we will never be able to process all of the nodes. That's why we are incrementing this here. If we are able to process all of the nodes, then we will return our answer. Otherwise we will return -1 from this. this. So that is the code for this. I hope this has helped you. Thank you so much for watching this video. Bye bye. I